We have 3 examples here, actually more, because I guess if you count the A, B, and C, so you have actually 5 examples in total on calculating the net force. So all of these are pretty good to force students, especially in kind of grade 11, or if you're doing foundational physics, to be able to do such questions. So let's take a look at these. I'm going to kind of break them down one by one. So here's the first one right here. So this one is going to be one of the easier ones that we have. So for this example, okay, we have numerous forces. Now I'm going to kind of draw these out for myself so that I can kind of see them. And you have force F1, you have force F2, you have force F3, and then I guess you have force F4. Now, they have certain magnitudes, so we have to kind of be careful with the magnitudes as we're going through. So we have our force F1, okay, so this is this particular force. This is not going to be exactly to scale, but this is at 150 newtons. Notice that it's east. I'm going to assume that east is in this direction. That's F1. Now I have a force which is 120 newtons, and that would be in the west direction. So this one, okay, would go in this direction. It won't be as big, but it is 120 newtons, and that's in the west direction. I have a third one, which is in the negative 55 newtons east direction. So negative east means it's actually in the west direction, all right? So here, okay, if you were to draw this out, this is not going to be very big. So it's going to be, this is the 55 newtons. And then the last one is negative 65 newtons west. So again, so this would be in the opposite direction in this case. So that's what you would have there. That's 65 newtons. Now that you have all of these, we want to be able to find what the net force is with respect to the east direction. Okay? So let's take a look and see. Okay, so what happens? So we'll make east positive. And if you're going to do that, so that's the summation of all of the forces, so that would be your Fnet is equal to, so now in this case, what we will have is 150 newtons plus 65 newtons, so that's these two, these are positive in the east direction. Then you have minus 120 newtons minus 55 newtons. Those are in the west direction. So what you would have in total, so if you take this, 150 plus 65 minus 120 minus 55, and that is 40 newtons right there. Now that particular 40 newtons, okay, so this is in the east direction. So the net force, okay, is going to be in the east direction. So you will have whatever object this might be, I guess, starting to accelerate in the east direction. Now, so within here, it doesn't really say anything about rounding, okay, or anything of that nature. So I'll kind of just leave it, okay, as it is, right? So let's say if this was to the whole. Now, I guess all of the actual measurements, so they all have 2 significant figures. So if you wanted to put this as 2 significant figures, you can. You can just put it in scientific notation, and that's what that would be. All right, so there you have it. So that's the first one. Now, the second example that we have, so that's this one right here. So this example starts to talk about, and let's see how it complicates things for us. So let's take a look here. Okay, so we're going to have to try to watch out for. So we have force F1, we have force F2, F3, so only 3 forces. We want to provide the answer in newtons, and I guess this is with respect to the up direction. So up is going to be positive for us. Now, this is a little bit annoying because of the fact that what you have in here is that some of the forces are in pounds. So notice that F1 is negative 2.7 pounds, right? Okay, so that's pounds, and this is down. I'll put a little D for down. So you would have to change this. Now, if it's negative, then obviously, so this is the same thing as 2.7 pounds. Okay, this is actually going to be up. And if you want to change it to newtons, well, 1 newton is approximately 0.2248 pounds. So that's what we have, and you can now change this up, so just by doing conversions. And that's going to be 0.2248 pounds at the bottom, 1 newton up on top. And so that would have been our result. So 2.7 divided by 0.2248. So that's approximately 12.01, 0.067 and so on. This is newtons. So I'm going to leave a few decimal places. I'm going to be rounding this. So all of them again look like they have two significant figures. So I mean, we don't need to carry too many here, but I'll just leave it, okay, in that case. So that's F1, and this is up, right? So this is the force, which is kind of pushing up. Now we have our second one, which is negative 12 newtons up as well. And so that's interesting. So we have F2, and it's basically the same amount. Now, sorry, this one is negative 12 newtons, and that's in the up direction. So that's the same thing as saying 12 newtons in the down direction. So, okay, so this is going to change for us. So one is up, one is down. They're about the same thing. One is a little bit more than 12, but not much. So these are going to pretty much cancel each other off. So this one is going to be in the down direction, as you see there. And then the last one, so that's another, unfortunately it's in pounds. So that's F3, and maybe I'll do it over here. So that's F3 equals to negative 1.8 pounds. This is up as well. So that means this is the same thing as saying 1.8 pounds down. All right, so this is another one which is going to be down, and you do the same thing. So if you wanted to be able to change it, you can multiply by this, because you have, I don't know if that's going to fit in there. Let me just kind of squeeze it in down. There you go. All right, so for this one, what you have in there, so let's try to do that. 1.8 divided by 0.2248. Let me swing that over. So that's about 8. All right, so 0.7 and so on. So we don't really need much of that. That is down. And now you can go ahead, right? So if up is in the positive direction, so this is with respect to up, right? This is what they want. So you can just start with the up forces and then just simply calculate them through. So actually this one right here, which I already have on the calculator. So this one is down, all right? So, well, let's go back to up there. So that's 12.01 and 0.67. I guess there's some other stuff, but we don't need that many decimals to carry. And then it's going to be minus 12, which is down. And then this is also down. So this is going to be minus right there. And that's going to be, 8, okay, 0.007, 0.007. We don't need much there. Okay, so notice what you get. So this is going to give me negative 7.996, 33, okay. Probably had some more decimals in there. And so now if you wanted to round this to two significant figures, so it's going to be just negative 8.0. And this is with respect to the up direction, right? Which really means because of the negative, the actual net force is down. That's what it would be, all right? So that's another example that you have in there. Okay, let's try the next one. All right, so now we have all kinds of forces in here. Now, luckily, they're all in newtons, so no conversions. 1, 2, 3, and 4. So the other example was kind of mean to us. So this is all in the same unit, so it's all consistent. And now we have 4 different forces. And let's take a look. Let's actually draw them out in here. So we have 1.87 newtons at 0 degrees. So this is going to be, so this is at 0 degrees. Now I have to I'm going to try to scale them. So 1.87, the other one's 4.2, 2.9. So this one's going to be the smallest. Now 0 degrees, okay, so this is basically if you're thinking of the axes, so x and y axes, so it's 0 degrees to the x-axis, okay? So whenever they give you the angles, okay, it always goes in this way. So that means the angle is going to be increasing, right? So this is 360 degrees. So this is 0, 45, 90, okay, so on, 180, and etc. Okay, so this is the first one. So that's 1.87 newtons, right? So it's 0 degrees. Okay, and it looks like this one is basically, so this is right in the x direction. Now F2 is 4.2, and this is going to be at 90 degrees, so this is going to be, you know, pretty much a little bit bigger than twice as much. Now 90 is going to be straight up, okay, in here. So that's going to be 4.2 newtons. Okay, this is at 90 degrees, so that means this angle is 90, right? So that's what we have there. So that's right in the y direction, right? So that's right there. The third one is 2.9 newtons. Now that's at 180 and 2.9, so it's a little bit bigger. Okay, and that's okay. It's going to go a little bit in this direction. Maybe not that big, but there you have it. So that's going to be 2.9 newtons. Okay, right there. I should make it a touch bigger. It should be bigger than the 1.87. And that is 180 degrees. So that means, so from here to here, that's 180 degrees. So this is in the opposite x direction, right? So notice that this one is going to be bigger than this one. Okay, so we're going to be working with the x and the y when we're finding out the net force. And then the last one for us, so that is 2.2 newtons, and I guess this one is at 270. Well, you know, 270 is all the way around here. So if you're going to put that in there, so this is going to be approximately, you know, 2.2 newtons. And notice it's in the opposite direction as the 4.2 that you have there. All right. Compute the x component of Fnet and the y component of Fnet, and then provide the direction relative to the x, y axes. Okay, so they only want the x and the y components. Okay, so that's going to be pretty easy for us to do. So we don't have to do much in here because they only want the net force with respect to the x and the y. Okay, so let's do that. So first, so in the x component, so this is the F net in the x component. Okay, so that's only going to carry out these two, right? So those are the only two forces in the x. These ones are perpendicular, so they have nothing to do with the x. So that is very simple. And I guess provide the direction relative to the xy. Okay, so well, I know that the one on the left is bigger. So this is going to be 2.9 minus 1.87. And, you know, so let's put that in there, 2.9 minus, and this is going to be minus 1.87. So right there, so it's, you know, 1.03. 1.03. Okay, you can round to 2 sig figs there, so 1.0. Okay, this is going to be newtons, and this is to the right. Now they're saying it with respect to the x and y, so this is going to be at 180 degrees. Right? Because that would be 180 degrees right there. So that's what we would have for the x component. For the y component, so if you're taking a look at the y component only, so right there, so what would that be? Well, so in this case it's going to be so this is 4.2 newtons minus 2.2 newtons, right? So this is the one up above is bigger than the one coming down, and therefore, so well, this one is actually much easier. So this is going to be just 2.0 newtons right there, and this one is, you know, straight up. So if you're doing this with respect to the degrees, it's at 90 degrees, or you can say up. Okay, so this one is up, this one is 180, which really just means to the left, and those are the two components, okay, that they were asking us about. So when they say just the y component and the x component, that is all that you would do, right? So you would just simply have these two components, okay, for the net force. And of course you can combine them, right? So as you kind of start learning about that, you can certainly combine those to see what the net force overall is, but that's not what they're asking you here. So that is it for this example. In the next example, so they ask us, you know, you have a bone in the human body and it looks like it's under several forces. And so within here, we want to compute the net force. Okay, so this one is a little bit meaner than the previous one. So let's copy this. Let's bring it down. Okay, so I'm going to paste this in here. Now, because we already have the free body diagram, okay, so this is for the next question. So I guess this is question number 8, okay, within here. Then we can certainly break this down already, right? So we can break this down into the x, okay, and into the y. So we have only up and down. So this one is actually really nice and easy to do. So notice this one is 90 newtons. This is 40 newtons. Okay, so the x component, which is going to be 90 minus the 40. So in this case, so that's going to be just 50, keeping the same number of sig figs. And this is going to be to the right. Okay, so that's going to be 50 newtons, okay, in this direction, right? Because that one overpowers it. That's your net force in the x. The net force in the y, on the other hand, it looks like the 140, okay, is bigger than the 120. And that would just simply leave you with 20 newtons, okay? So that's what you would have right there. That's what you would have, okay? So you have 20 newtons and then the 50 newtons, and the 20 newtons is upwards. Okay, so that one is up. So what does this actually mean? So if we want to know the net force, so that's going to be our net force is equal to, well, it's composed of your x component. So it's going to be composed of this, which is 50, right? And then it's going to be composed of this, which is 20. So it's not going to be as big. That's 20 newtons. So what's going to happen is that you're going to have, so if you actually did this, okay, so throughout, so if I take this, I'm going to duplicate it, right? So you can put it, okay, in terms of vector notation. So that's going to be heads to tails, okay? And our net, okay, is going to look something like that. All right, and then we can measure what that is, and then we can find out what this angle is right here as well. Well, let's do that. All right, so for this particular example. So what do we need? Well, first of all, the magnitude is going to be the combination, so we can use the Pythagorean theorem. So the magnitude of Fnet, okay, so magnitude we can write like this, at least for the moment. Okay, so those are absolute values. That just means how big is this vector. And if you remember, so Pythagorean theorem, because we have a triangle in here, okay, so this is the hypotenuse of the triangle, right? So this is 50 and this is 20. So this is 20 squared plus 50 squared, and this is going to be square root in that way. Okay, so let's compute it. So that is 53.851, etc. Now we wanted, okay, I guess we'll just keep everything to 2 sig figs. So that's going to be 54 newtons. Now we do need to know what the angle is in here. Okay, so in order to find this particular angle, so you're going to have to use your knowledge with regards to kind of tangents. So that's going to be 10, okay, inverse of the opposite over adjacent. Right, so this is going to be opposite is 20, adjacent is 50. All right, so that is just from trigonometry. So let's see what that angle would be. So within here, so I'm going to just kind of go back. So 10 inverse, so this is 20 over 50. Okay, and that angle is approximately so 21.8. I'm not going to round this. I'll just put degrees over here. So what that is telling us is that this right here, okay, is 54 newtons. And then the angle that it makes with the x is going to be, approximately 21.8 degrees. And that's your net force. So it would be the combination of the magnitude and then the direction itself. And that's all that you would have for this example. Here's the last example, which basically says, repeat, okay, what we have just done, except we want to be able to replace these. So it's kind of, playing with our mind just so that we can see, okay, so the 140 is now 8.6, okay, and then etc., etc. So let's, change them up. So I guess, what I'm going to do is I'm going to take this and I'm going to duplicate it. Okay, so let's bring it down. And then I'll just very easily just, kind of change these up in here. Okay, So we have, so 140, so this is no longer 140, this is 8.6 newtons. Okay, so that's the first one. The 90, okay, is now 2.8 newtons. That's the second one. The 120 is 5.5, so this is 5.5 newtons. And then the 40, okay, is 6.1 newtons. And now you're playing the same game. So, you know, if you're going to do that, so you're going to have the x component. So my x component is going to be, so if we do this, so it's 8.6 minus 5.5. So we have 3.1 newtons. So that's the net force in the x, okay, which was 8.6 minus 5.5. So that is just those two forces. And in my apologies, so this is not in the x, this is in the y. Okay, so let's put that, that's in the y direction. Okay, so it's up and down. So it's good that I caught that. So that's that. And now the other one that we have, so now it is going to be x. So notice x is actually, okay, so it's 6.1, so that one is bigger. So that's Fnet to the x. This one is going to be 6.1 minus 2.8. And so that's 6.1 minus 2.8, which is 3.3. Now notice that this is to the left, right? So that's going to be, you know, to the left or at 180 degrees. So just keep that in mind. And then the other one is actually upwards. All right, so now we have those two forces. So again, as you're going to be doing this, so you have 3.1, which is up. That's 3.1 newtons. And then to the left, okay, so basically, well, this is going to be almost, it's going to look exactly the same, just a little bit bigger. Okay, so this is what we have right there. And again, so as you're doing this, so we need a triangle. So duplicate this. I'm going to do that. And really, our vector is the vector which is going to look something like this. And with that, don't forget this is 3.1 up. So now you have your triangle. So now you can find your angle, okay, and you can find your magnitudes. So again, so the net, okay, is going to be, so the magnitude for this, right? So the magnitude of this, so we have the square root, and this is 3.1 squared plus 3.3 squared. So let's see what that gives us. Okay, I already have 3.3, so that, and we want to be able to square that. Okay, I'm going to kind of go back because I need the square root of the whole thing. So 3.1 squared plus 3.3 squared. And so within here, so with 2 sig fig, so I guess it's 4.5 newtons. And now if you want to know what the angle is, so that's going to be the 10, okay, inverse. And this is going to be really good because this angle, guys, that you have in there is going to go, you know, all the way around. So we're finding the angle that we have there, which is, you know, opposite over adjacent. So that's going to be 3.1, and this is going to be 3.3. So let's see what that angle is. So as you're going through, so 10 inverse, so 3.1 divided by 3.3. So that angle is approximately 43.21 degrees, or 43 degrees. But that's just this angle right there. Now, if you want to know, so if you were writing this out, then this is interesting because how should you write it? Because it's not going to be at 43.21. So if you want it with respect to your x value, so that means you would need this angle, right? Not this angle right here. But this angle right here that you have is just simply 180 because, let me get rid of this. So because what you have is that's 180 degrees, right? Minus this angle, and it's going to give you that. So if you were writing this in, your actual angle that you would have in there, so this is going to be your vector. So your vector is in this direction, and then if you're doing your angle with respect, so I'm going to just draw a vertical line, a horizontal line, So it's this angle that we want, right? So I'm going to call this, angle 2. I guess this was maybe angle 1. Okay, and this is the angle 1. So it's going to be 180 degrees minus the 43 point, put 21. And what does that give me? Let's see, I'll take the calculator out. Okay, so here's my answer actually. That was negative, so minus 180. Okay, so this is going to be 130, 6.7 or 0.8 degrees. Okay, it's not negative. I just had on the calculator, so I did the reverse. Okay, so it is positive. All right, so that's what you would have. So here's your magnitude. So magnitude is 4.5 newtons, and this is the angle with respect to x. And that is it. So that completes that last example. Thanks for watching. Happy studying.